Okay guys, we're going to take a look at a couple of examples that use the Pythagorean theorem. So just to go over it really quickly, this is to do with right angle triangles. So if you take a right angle triangle like I have here and label it A, B, and C, label the sides A, B, and C. The important thing is that C is always the hypotenuse or the longest side of the right angle triangle, which is the side opposite that right angle. Okay, and the relationship is that if you square the two shorter sides and add them together, that is equal to the square of the longest side. Okay, so this is our theorem. Now, if we want to find out the length of the hypotenuse or the longest side, this is how we would use it. But sometimes we might want to find one of the shorter sides, and in that case, you simply just rearrange the formula so that you would have a squared is equal to c squared minus b squared. Okay, or if you were trying to work out b, you would get b squared equals c squared minus a squared. Okay, so the important point is here, if you're trying to find one of the shorter sides, you're going to take the hypotenuse squared and subtract from it the other side squared. So let's look at a couple of examples. Okay, in this first example here, we're given a diagram, and the first thing we need to find is the perimeter of the triangle. So to find the perimeter, we need to know all three sides of the triangle. So in this case here, we'd be looking for, I'll just label it A, because it's one of the shorter sides. Okay, so because I'm finding out A, I'm going to use the formula A squared is equal to C squared minus B squared. And so this side here would be B, and then the hypotenuse is C. Okay, so to work out A, what we have to do first is plug in B and C into our formula. So we're going to square 18, which is 324, and then subtract from that 5 squared, so subtract from that 25. So that means A squared is equal to 299, so to work out A, we would have to take the square root of 299. Which, using my calculator, gives me 17.3 to 1 decimal place, and that's 17.3 centimeters. So the original question A here is, what is the perimeter of the triangle? So to work out the perimeter, we would just add up all three sides. So the total perimeter would be 40.3 centimeters. Now I'll just move that up. Part B says what's the area of the triangle. So remember, area is base times height divided by 2. And in this case, the base is 5. And the height is our 17.3 that we found. And then we would divide that by 2. So 5 times 17.3 gives us 86.5. Divided by 2 gives us a total area of 43.25 centimeters squared. Okay, the next question we have is a word problem. It says Eli and Russell are painting a border along the top of a wall. If the wall is 3 meters tall, so here I'm going to draw in my wall, 3 meters tall, and they have a ladder that is 4 meters long. So a ladder would lean up against a wall like that. So that's my ladder, and it's 4 meters long. And the question is, how far will the base of the ladder be from the base of the wall? So we're looking for this distance here. Okay, so again, we've got a right angle triangle because the wall and a floor would make a right angle. And I'm going to label my sides. So again, I'm looking for A, this is B, and this is C. So I'm going to use A squared is equal to C squared minus B squared. And then I'm going to fill in my variables. So A squared is what I'm looking for. C squared would be 4 squared minus B squared. B is 3. So I get A squared is equal to 16 minus 9. Or A squared is equal to 7. So A is going to be the square root of 7, which is about 2.6 meters. Okay, so, and we were told to round your answer to the nearest tenth. So 2.6 meters. So the ladder is 2.6 meters from the base of the wall. Okay, so question 3 is a little bit tricky because it's a 3D shape, so we really have to visualize it. So we're looking for the distance from X to Y, so that's like sort of a diagonal through that box there. And where we would make our right angle triangle is here, And then if you think about the diagonal across that bottom box there, so that's actually a right angle triangle if you visualize that in 3D. So we're looking for this length here, which is a hypotenuse. Now, we know this is 6, but we don't know this length here. And looking at it, this length here, and I'm going to do this in a different color, is actually the hypotenuse to this triangle here. Okay, so the first thing I want to work out is this distance there. So I'm going to redraw that triangle. So it was 12 and 10, and what I'm looking for is that hypotenuse there. So to work that out, I would do c squared is equal to a squared plus b squared, because I'm trying to find the hypotenuse. So if that's a and that's b, I would get 10 squared plus 12 squared, which is 100 plus 144, or 244. So to work out c, I would take the square root of 244. Okay, and c, I'll take it to 2 decimal places, is 15.62 centimeters. Okay, so now back to my red triangle here. So basically what I've worked out is that distance, which is 15.62. Okay, so now if I want to work out xy, that there is also a hypotenuse, so I'll label it c. I would do c squared is equal to 6 squared plus 15.62 squared, and then I would work out c in the usual way. So 6 squared is 36. This number squared we know is 244, so we just sort of found that in here. 36 plus 244 is 280. So c is going to be the square root of 280, which is about 16.7 centimeters. Okay, and that's our final answer there. Okay, so you can go on to the independent practice now for this lesson. Thanks, guys. Bye.